Hi, and welcome to our third in the series of TrueLoad videos, training videos here. So today we're going to use TrueLoad to take the simulated strain results we generated from the pre-test video and bring those into post-test and generate loads and take a look at what we get. So let's get right into it then. So I'm back in my folder with all my files that we've been working on, and I'm going to come in and type TrueLoad app to launch TrueLoad, and let's get going. Okay, so we're in the TrueLoad environment here, and now to get started, I'm going to go straight into the post-test app. So post-test is the third icon on the toolbar. So we're going to launch post-test. And the post-test app here, we've got a couple of fields to fill out. So the first one here, we need the TLD file. So we're going to browse for the TLD file we created last time, which you called headlamp. And we're going to just load that in. And you'll see the things that we've been looking at here. Here's our gauge placement and the plots, which we didn't talk a whole lot about last time, but there they are. So we know we've got our TrueLoad file up. And now we're going to be using strain data that came from the FEA file. And the strain data from the FEA file is not in microstrain. It's going to be in strain. So we're going to uncheck the microstrain flag here on this main form. Normally when you get data from the test area, that will be in microstrain. But in this case, we're going to uncheck microstrain. And now we're going to load in the strain data file to start our work. So I'm going to just browse here. And it's filtering on TFU files to start with. I'm going to change the filter to be a CSV files. And here's our SimTest headlamp, the one that we generated last time. So let's grab the SimTest file, the SimTest headlamp file, and open that up. And let's load that in. So we're going to say load in the strain data file. And then to take a look at it, we can plot it up if we like. And there's the strain data that we generated off the gauges from pre-test. And this would normally be where we get strain data from the test environment. But in this case, we're just using simulated strain data. But normally you would be working with your strain data directly from your test data here. And there's tools here where we can map and drop channels. So if we click on the map and drop channel form, you'll see that we've got all of the FEA gauges and then all of the gauges from the data file. Okay, so we can map them to different channels, to different gauges. If we need to move things around, if your test guys didn't get them right, or if a gauge failed in test, we can just drop a gauge. Okay, so you can just drop a gauge easily. But I'm going to just cancel this and not keep anything. Don't want to screw anything up. And then this button again is to plot the strain data. Okay, so there's everything there. And now it's pretty simple. I'm just going to click the calculate strain button, calculate loads button. So that's about it. We load in the TLD file, we load in the strain data, and we push the button. It's as anticlimactic as it gets. Now, to be fair, this thing that we're doing is going to be linear superposition to linear superposition. This is going to be as good as it gets. We're going to get zero error here because of the way the mathematics are. But normally, if we were dealing with real test data, we'd get a couple percentage error in these traces. But it demonstrates what happens. Okay, so it's doing all its stuff, and we've got a HTML file here with all the information in it. And I'm just going to zoom out my HTML file, and I need to refresh. Really important to refresh your HTML file. So just refresh the HTML, and then there's hyperlinks here that get you to important parts of the document, which when you're working on things regularly, this really helps save you time to jump to the right areas. But we're just going to scroll through top to bottom. Okay. So here's all the data, all the important information that we use to create these files here. And then here's our load table. from pretest. And then here's our gauge table. So here's our gauges 1 through 6, and the element labels. Okay. And then here is and then here's the strain channel it was mapped to. So this would normally be your test strain channels, but in this case these came from our FEA model, so they've got these names to them. Normally these would have you the names of your strain channels from your testing. And then you see some of the plots we've been looking at. So just the standard plots. Okay. And then look at that. Here's the first load signal it recovered. So here's a sine sweep on the first load case. Here's another sine sweep for the second load case. And here's a random signal for the third load case. And then what we're seeing here are the strain correlation plots. So this plot right here, the green curves are the measured data that came from the data file. And then there's actually blue curves. You can't really see them because they're line on line. But blue curves are created by taking the measured strain data times a correlation matrix to produce the loading functions I just showed you. And then the true load post-test software goes back in the FEA model and pulls out the strain response at the gauges and plots those up in blue here. So we've got green curves are measured data, blue curves are simulated data. And then next to us here, we've got a correlation plot here that shows measured strain versus simulated strain for all of the gauges. So this is showing that we've got perfect correlation in this situation. And then as we come down, our error table, again, because this is a made-up problem, we've got 0 error, but it's showing you the strain correlation. And then we've got gauge by gauge how things went. Green is measured, blue is simulated, and showing you each one with the cross plots next to it. Okay, so this is what we get. And again, with the real strain data, we'd see some errors, but that's what it is. And then at the end here, we've just got some snapshots of standard views of the gauges. Okay, so that's the post-test report. Okay, so the important thing about post-test is it's going to generate an HTML report that shows you how well you did, and then post-test also generates a couple of data files. Number one, it's going to generate a data file called your data file name .tfu. And that's going to be the function file with all the loads in it. And then it will also create a QSE file, a quasi-static event file, that will match each of our unit loads to the functions in the TFU file. So these are really important files here. All right. So let's come back here into TrueLoad. And what I'm going to do now is I'm just going to put away the post-test window. And we're going to go now into QSE and pull up the event that was just created here. Okay. So now this is now a quasi-static event that was generated by the strain data. We can plot it up. We can probe any nodes here for any data we want. So I can come in here and choose a couple of nodes. Come in here and choose that node. Not that node. That node. And that node. And I'll get a couple more. I'll grab that one and that one. Okay, so I've got 4 nodes chosen here. So we got 4 nodes. And let's just plot up, let's say, the Z displacement and say apply. And now we can see that we have got the Z displacement based off of those strain data files, that strain response that we measured. Okay, so now we can generate anything we want. So I can do this for displacements. We can do it for stresses, and away we go. So we can generate any set of data that we want here. It goes nice and quick, and probe anywhere you want in the model. We can get any data we want, not just at the gauge locations. We can do that at nodes. Okay, I had to take a little pause here because what I wanted to show you, we have a little bug in the software. So I'm going to show you a few other things about what we just did, and we'll call it good. Okay. So right now, what I want to do is compare the loads that TrueLoad calculated to the original loads we put in our file using the QSE file, the try1 QSE file that we started off 2 videos ago. So what we're going to do is I'm going to close up post QSE. So we're just going to close up QSE here, and I'm going to go into the TFU manager. The TFU manager is the function managing form utility. We saw it briefly in the first video, and this is what I'd like to do is let's go in and let's grab that SimTest headlamp TFU file that we were just using to generate the results, and let's load that in. And there's our 3 functions for our 3. Let's go in and append in to this TFU file just so we can do all the plotting together. I'm going to come in here down on the bottom in the import options form. Let's import a TFU file, and we're going to import the try1 TFU that we started off 2 videos ago. And just say OK, and so there they are. And so now let's just check off Sign01 and SimTest for the first frame there, because that's how we set the functions up. And let's plot that up and see what we get. And as you can see, the 2 functions are line on line. So TrueLoad is able to back calculate the original functions for the first load case. Let's try it for the other one. Let's grab these 2 now and plot those up. And look, they're line on line. And then one more time, let's grab the 3rd function that TrueLoad calculated with her original random function. And there you go. And they are line on line as well too. Okay? So this is just a nice little demonstration of how TrueLoad is calculating the loads and getting them exactly right. And thank you very much. Hope to have one little bug taken care of, and I can do a little update video in another week or so. Okay? Thanks a lot. Bye.